Hi, this is Slava Kurilyak, and I want to welcome you to another live stream sponsored by Produvia. I am the founder CEO at Produvia, where we help companies around the world to scale to the next level by developing AI technologies. I want to welcome you. I want to invite everyone who is joining us to let us know where you're joining from. This is a live stream and aimed to be interactive. This live stream is meant to give you value, and I encourage you to leave a comment in the chat section below or on your right to where you're from. Let us know your city, let us know your country, and I am more than happy to give highlight to you and your location. I am personally from Vancouver, Canada, and I'll start this off by making the statement here in the comment section now that this is my area where I am currently, and I encourage everyone else to do the same. This live stream is aiming to educate, inspire, and share best practices for how entrepreneurs, executives, and decision makers can use AI and machine learning technologies to scale their business to the next level. This live stream today is talking about the topic of automotive and AI. Automotive space is a fascinating domain that a lot of companies are starting to rethink. Recently, we've had some major breakthroughs that came from artificial intelligence, and it has changed how people thought about the concept of a driving vehicle. I want to share the vision for those who are not familiar. A company like Tesla has envisioned a better world, a world where cars are self-driving. In this world of full autonomy, we see car manufacturers aiming to create the next generation of vehicles that do not require a driver to control the vehicle, a driver to navigate the vehicle. We are now operating in a new domain where the driver is not a human. The driver is virtual or powered by AI technologies. This is a fundamental shift that has happened in the last 5 or 10 years, where companies have developed technologies that have enabled them to achieve full autonomy. Now, not all companies are operating under this domain. Some companies still have a person behind the vehicle. They still have a person navigating, controlling the vehicle. And so it is a spectrum. I want to lay out the foundation. The ultimate vision for a company like Tesla, for example, is to achieve full autonomy. Having said that, there are companies who are not on that scale yet. And so how can they achieve full autonomy? And this is actually a topic that others have written about from the vehicle side. Personally, myself, I've written about this topic from the organizational side. But in a nutshell, there are 6 levels of full vehicle autonomy, 6 autonomous levels, right? We go from the foundation, which is no automation, level 0, all the way through full automation, level 5. So if anyone's interested to learn more about the concept of full autonomy, I highly encourage you to check out full vehicle autonomy and look at companies like Tesla who are already on their way to achieve this. So for everyone else, if you're interested to learn more about full autonomy on an organizational level, I encourage you to reach out to me and I will send you a link to full autonomy that I've written about on the company blog. This is a post I put out at the end of 2020. called Organizational Levels of Autonomy. And what I'll do now is, for convenience, I'll share the link with anyone who is interested to use it. So that way, everyone will actually have a chance to read it. Okay, let's get into the topic. Today, we're discussing AI and the automotive space. And I want to start this live stream by sharing my screen. Hopefully that gives everyone indication of what I see. Perfect. We're now able to see side by side. Hopefully I make it a little bit clearer for you. This particular presentation is meant to inspire, educate, and share best practices for how individuals and companies are using AI technologies. And the automotive space, I think, is fascinating because it shows us as people the potential to create fully autonomous vehicles. And I wanted to take the time for this particular presentation to focus on what will it take for a company to achieve that vision. Having said that, and there are so many applications of AI technologies, and yes, this technology can be applied to help automotive companies to generate revenue, reduce costs, or save time. But for the purpose of this particular live stream, I wanted to focus specifically on how can companies achieve full vehicle autonomy, right? This is a very specific domain that we're solving here. The vision is, how can a car drive itself? How can a car navigate on the streets by itself? How can a car pull out from a parking lot and do that automatically, right? All of these questions are important to consider when we're thinking about full vehicle autonomy. So let's dive deeper into the topic. I will now make sure that you are able to see my screen here, so bear with me. Perfect. We're going to discuss 5 AI use cases for the automotive space. Mind you, there are many ways to apply AI technology, and in this particular live stream is aiming to just discuss the 5, right? We don't have time, unfortunately, to go into a variety of use cases. And so I wanted to focus on the 5 most essential use cases or applications of how you use AI technology to solve automotive problems. And the first is autonomous driving or navigation. And this is a very important domain to solve because it allows us to really understand what technology we need so we can achieve full driving autonomy. Okay, so what does that mean? So autonomous vehicle is a task of making a vehicle that can guide itself without human conduction, right? And this is important to understand because we're not controlling the wheel, we're not controlling the power to the vehicle, we're not necessarily telling where to go, but we are asking the system to navigate itself. So the first technology we're going to consider is autonomous driving. So how can we achieve autonomous driving or autonomous navigation? Well, today the technology of choice is computer vision. For those who are not familiar with computer vision, it's a technology that's aiming to make sense of images and videos, right? It's a computer science terminology that helps us to leverage data to interpret images and videos. And autonomous driving falls under the computer vision domain because ultimately, if we need to have a car drive itself, we need to have the car navigate using cameras and sensors. And this is why computer vision technology is helping us to achieve that vision. And I encourage everyone who is joining us today to leave a comment and make statements. This is an interactive live stream, and I want to bring as much value as possible, but I also want to make this a two-way conversation. So feel free to do that at any time. Let's move forward. So if we understand that we must solve computer vision problem, then we need to really understand that this domain can be solved using multiple approaches, right? How can we achieve full autonomy? Well, one of the applications that we must solve is something called object detection. I will get into this particular problem with an upcoming slide. And another problem that's very important is semantic segmentation. So these are terminologies used by computer scientists, machine learning practitioners, who are aiming to understand what's inside the image, what objects are inside the image, and where are the ends or the extents of those objects. Where are the boxes, the bounds, the maps of these objects, right? These are all terminologies used to interpret images or videos. So let's consider some of the high-level approaches first. Before we dive deeper into autonomous driving or navigation, we want to understand what companies are doing today, right? And this will give everyone a chance to understand what are the best practices today. Okay, let's consider a company that is closest to achieving full autonomy. Now, there are many automotive vehicle companies out there. From my perspective, Tesla, owned by Elon Musk, is the closest to achieving that reality. And the way they're going about this is that the Tesla team has decided to focus exclusively on camera data. The Tesla team has installed cameras around the vehicle, and these are traditional cameras as what you expect sort of from what you see when you take your phone, when you use your laptop, when you see a camera as you walk into a store. This is the context that I'm describing. It's a traditional camera that's capturing light. We're simply capturing the spectral light of the camera. So in the context of a vehicle, Tesla is using multiple cameras to capture data of the world, right? And this is the data input that is necessary for computer vision models to achieve full autonomy or guided autonomy. Now, there are other approaches. So I've mentioned to you using a camera is one way to go about leveraging data to achieve autonomy. But there's another sensor that is very commonly adapted in the automotive space, and which is LiDAR. So for those who are not familiar, LiDAR is a very important technology, and it really is using light detection and ranging to make sense of the world. It's a remote sensing method that uses light as a form of pulsated laser. So it's pulsating laser with different ranges at different angles. And depending on the response it receives, it's able to make calculations about what's ahead, behind, or to the side of the vehicle. So LiDAR is another very common approach that companies take today to visually understand the world. Now, LiDAR is controversial in some domains because it does force companies to install additional sensors. LiDAR sensors are different. Sometimes you see a vehicle and it has a mount of cameras on top, and usually this mounted structure appears different than a traditional camera. And this is actually one of the reasons why LiDAR is controversial, because they look like retrofits, if you were, to vehicles. And there are a lot of companies who use LiDAR to better collect data of the driving environment. Now, a company like Tesla is also controversial in their use of traditional cameras because they do not use LiDAR. So companies, automotive companies, are making a choice. They're deciding what is the best camera technology to use to visually understand the environment of the driving vehicle. And LiDAR is one choice, traditional camera is another. And there are many different sensors out there that are able to help vehicle companies to understand the driving space. You know, these choices are from proximity sensors all the way through more advanced sensors. And the sensing technology is one of the choices that companies must make when deciding how to achieve full vehicle autonomy. And then the architectural choices, the technology that they're using to understand the camera data or the light data is another element to consider. So I want to dive deeper into the next topic of our discussion, which is, can we achieve full vehicle autonomy? And the answer is yes. This is not a question of does the technology exist? This is a question of, do you have enough data? You know, the technology is available to anyone who wants to use it. I've mentioned to you and gave you a glimpse of what technology is necessary, and that is computer vision. You need to use deep learning models that have been trained to solve computer vision tasks in order to achieve this goal. And so the only obstacle that stands in our way is data. And this is where companies must get started with data collection. They must get started with data labeling. They must get started with data processing. Without data, autonomous vehicles will not be possible. It will not be realistic. It would not be accurate enough for the vehicle company to put these technologies into production. So in the initial stages of data gathering, the best thing you can do is to give value to the data process itself. And once you become data-driven, once you're collecting light data, for example, or LiDAR data from the vehicle, now you start to consider, okay, the data is there, let's start to apply technology on top. As that happens, you can slowly start to shift from developing proof of concepts to proof of prototypes and all the way through production. So once you have data, then you can start to move your way through the research and development cycle. Until then, data is the missing link. So I want to emphasize this, that you do need data. You do need to give importance to data in order to move forward with autonomous driving or autonomous navigation. The next point I wanted to mention, which is something that I alluded to before, which is semantic segmentation. Semantic segmentation is very important because it allows individuals and companies to understand where is the extent of an object. So imagine you have, for example, a scene, and that scene contains pedestrians, that scene contains a walkway, other vehicles, other objects. Semantic segmentation allows companies to create a mask around each object inside the scene. And so when you give a mask, now you can start to differentiate what is happening. You can start to realize that, well, perhaps one object is moving across the scene, and perhaps that object is a pedestrian. So by understanding the extent of the object itself, by giving importance to similar pixels inside the image, we can start to give importance to certain objects like pedestrians, right? And this is critical if we want to achieve full autonomy. We need to give importance to pixels, and those pixels will be created as a result of a semantic segmentation model. So, to recap, semantic segmentation is a technology that really allows anyone to cluster pixels together based on a specific class, right? It's a form of pixel level prediction because each pixel in an image is classified according to a category. And there are many benchmarks for this, so I encourage you to look into semantic segmentation, or another way to look at it as pixel segmentation for this domain. And it's very important to solve as practitioners. So what can we do, right? Semantic segmentation models, with them, we can teach computers to detect not just objects, but boundaries of objects, right? That's important. We're aiming to understand what is the boundary of what we're looking at. And for a vehicle, we need to understand where is the boundary of pedestrians, because the last thing we want to do is come closer to the boundary of a pedestrian. We need to detect pedestrians, and we need to understand what is their boundary. We don't want that vehicle to come close to the boundary. So this is an example of how we can create a safer vehicle. We can give importance to objects, and we can do that by doing something called semantic segmentation. Okay, so the next idea that I wanted to share with everyone is the idea of 3D object detection. Okay, so let's recap. And so far, we've discussed semantic segmentation in our ability to achieve autonomous driving, but we also need to solve an important problem called 3D object detection. So let's recap to what object detection is. 3D object detection is where we classify object categories and we estimate the oriented 2D bounding box of physical objects from 3D sensor data. So in other words, we're making sense of what is the object inside an image, and we're extending that idea into the 3D space if we're doing 3D object detection. And that's important for vehicles because we need to understand not just where a person is, but where are they in relation to the vehicle? What are the dimensions of the person, right? We need to understand the 3D shape of the person in order to better navigate the environment of a self-driving vehicle. The only way to do that is to do something called 3D object detection. And now, object detection is the goal of figuring out what is inside an image or video, what are the objects, and now we need to give that, sort of solve that problem in the context of 3D. So it's a harder problem to solve than 2D, but it's worthwhile to solve. And I wanted to bring this to everyone's attention because it's very important. Okay, so far we've discussed semantic segmentation, we've discussed object detection, and I also want to talk about another concept, which is called, before we move forward, 3D object detection allows us to teach computers to detect objects in 3D, as I've alluded to before. The next topic is simultaneous localization and mapping. This is a critical problem to solve if we are to make sense of the camera data we're collecting, if we're to make sense of the visual data we are collecting. Simultaneous location and mapping simply refers to the fact that we need to know the position of the vehicle at all time, and we need to know the map or the surrounding of that vehicle. Okay, so let's consider a few approaches here. So one approach is we rely on external maps to guide the vehicle in the transportation process, right? The mapping is not done by the vehicle, the mapping is done externally. The vehicle is doing localization. In other words, it's orienting itself and its position in regards to the scene. That's sort of approach number one. Approach number two is where we're aiming to map locally while the vehicle is in motion, right? We're creating a map as the vehicle drives itself. And right, this is an interesting idea where as the vehicle moves forward, we extend out, imagine 10, 100 meters out, or feet, depends on where you're journeying from. And we're aiming to interpret what we're seeing within that bounding box. And so as the vehicle moves forward, every single sort of stepping stone, we're creating a new map, and we're updating the map as the vehicle moves forward. This is localized mapping. So localization is helping machine learning practitioners, data scientists, deep learning practitioners to understand the relative position of the vehicle with respect to its environment. And mapping allows the same practitioners to create a mini map as the vehicle drives itself. So there are two approaches, as I've mentioned, global or local mapping. And the goal of this particular model is to answer the question, can we teach computers to create a driving map? And the answer, as you can already guess, is absolutely. Right? This is one of the best ways to leverage technology to make sense of the environment in a driving vehicle. We can create a map. We can understand what's in that sort of map if we start to combine technologies together. So for example, we can use semantic segmentation, object detection to detect where pedestrians are. And we can also use localization and mapping to understand the vehicle's position with respect to the pedestrians. This is how we avoid accidents. This is how we also achieve full driving capabilities. We solve one task at a time, right? I want to emphasize this, that AI technology is solving one task at a time. The best AI technologies today, they seem hyper-human or hyper-realistic only because they're solving one thing very well. Now, you may say, Slava, but I'm pretty sure that a company like Tesla is using more than one model, and you are correct. Tesla stacks different deep learning models or neural networks in order to come up with its own driving solution. Other companies are doing the same. You can use the technology to solve one problem at a time. So I want to emphasize this, that the best AI technologies today are simply artificial narrow intelligence, ANI. They're solving one thing and one thing well. So if anyone's interested to use AI technology to automate the automotive space, they need to let go of the desire to create a system that can understand how to do everything. They must embrace the concept of doing one task and doing that task very well. And when we chain sort of models together, when we chain different problems and their solutions together, we're now achieving what we associate as an intelligent system. So in other words, we're simulating intelligence by solving one task at a time. For that reason, we not need to fear these systems. We need to embrace them because they empower us to move forward with greater flexibility. If we know we're being augmented in our technology efforts by using technology that helps us to do one thing very well, we're now able to move forward freer. And so I wanted to emphasize this as an important distinction to make. And let's jump into the fifth and final use case of AI technology for the automotive space, which is pedestrian detection. So I briefly have alluded to here, this is an important domain to solve because we need to prevent accidents. This is an industry where an accident will cost millions, if not billions of dollars of damage to any vehicle company that uses AI technology that does not perform its function, that does not perform the function it was intended to perform, which is either assisted driving or full autonomy. Preventing crashes, preserving human lives is critical. It's by far the number one metric to aim for. Creating systems that are not only preventing accidents, but also ultimately preventing deaths. Now, from the preservation perspective, the way to do that is to apply, as I've previously mentioned, object detection, apply semantic segmentation, and we're aiming to solve the problem of pedestrian detection. So what is that? We're basically detecting pedestrians from a camera. And a lot of the state-of-the-art methods of accomplishing this can be achieved using 3D object detection as opposed to 2D object detection. And that also implies that if we have cameras that are detecting the environment, detecting the scene, then we need to rely on multiple cameras. And actually, this is the approach that companies like Tesla take, is that they rely on several cameras and they're interpreting that data. And what they do behind the scenes, and again, I'm not affiliated with Tesla. I simply am observing Tesla from the side. From an AI practitioner's perspective, I bring my comments and my opinion to the table, and I encourage you to do the same. I encourage you to look at companies who are already using the technology and ask yourself, what can you learn from them? So as a foundation, what I can learn from Tesla is that leveraging multiple cameras or multiple sensors is the best practice that allows us as humanity to achieve 3D object detection and pedestrian detection. And what Tesla team is doing is they're combining each camera as input to a neural network that creates its own map. For those who are not familiar, neural networks are another acronym or name to describe a deep learning model. And ultimately, this is a model that does not require Tesla team to be explicit in the features. It requires a Tesla team to leverage the internal architecture of the deep learning system to come up with its own understanding of, for example, what is a person. When you have multiple cameras being collated, when you have multiple videos merged into one deep learning model, now you have a meta model that's able to make sense of individual camera data, and it's able to cohesively create a local map of the driving environment. This is how Tesla operates. They are combining cameras, feeding them into a single neural network. And by single, I mean multiple data sources fed into one meta model that is able to generalize and create a map of the driving environment. And the end goal is to understand what's happening around the vehicle. And when you combine this idea with, for example, autonomous navigation, now we can make sense of how we can achieve full autonomy. So if you have a local map, a map that's generated on the fly in real time as the vehicle drives itself, now you can combine that technology with the concept of steering. if you can perform automated steering through remote control or even on-premise control, then you're able to navigate the vehicle by itself. This is a groundbreaking technology powered by AI technology. And what's happening is that, for example, when an AI system, when a neural network detects a pedestrian crossing into the path of a vehicle, the autonomous driving function, which is a different model, this is the concept of stacking models. A different model is now navigating the vehicle in such a way that it minimizes the impact to the vehicle, it minimizes any impact to the pedestrian. And so this is how you achieve full autonomy. You combine multiple deep learning models, you use the state-of-the-art methods in computer vision technologies, and you're creating something that is seemingly intelligent. And this is a good moment to reflect on not just what's possible from the automotive sort of full autonomy perspective, but what can AI help autonomous companies with? So imagine, for example, that you already have the vehicle on the road driving itself. So what else is possible? Let's talk about some of the other, I would say, very important use cases of AI technology. If we're not aiming to, let's say, once we've achieved full autonomy, what else can we do? Well, we now start to think, how can we improve either the user experience of the driver, or how can we use AI technology to improve the business operations of the company itself? From the user's perspective, one thing we can do is we can call upon the vehicle using our voice or our body language. Imagine pulling out your phone or your watch and talking to your device. That device triggers the vehicle to come next to you, right? So you're interpreting the voice, you're performing something called speech recognition, you're understanding what's being said through text classification or named entity recognition, and you are activating the autonomous vehicle to find you based on your position, based on your GPS location or global positioning system. So in this use case, as a user, you are speaking using your voice and you're activating your self-driving vehicle to drive to you. This user experience is quite remarkable. You're able to not do something physically, you're able to just use your voice, and your voice triggers a series of deep learning models which are activating the vehicle to come to you. Right? This is how we can improve the user experience, the customer experience, who owns the vehicle. Now, there's another way to think about AI technology. Mind you, there are many ways to think about AI technology, but let me share a few additional examples. Imagine you are the automotive company and you want to use the technology to improve the production, manufacturing, or distribution of vehicles. You can use AI technology along that process. You can use it as a form of robotics to help you to manufacture products faster. You can use the technology in terms of robotics to help you manufacture products safer. And you can use the technology to help you plan and optimize the production process itself. Right, there are just 3 small examples of how you go about using the technology. And again, the specific problem that you are aiming to solve would really depend on where you see the opportunity to use the technology, as well as what are your biggest frustrations. So for our future listeners, for our existing listeners and watchers, I highly encourage you to think about what problems do you face today? Are you an entrepreneur, executive, or decision maker working in the automotive space? What frustrations do you face? What challenges do you want to overcome? And if you're joining us live, feel free to leave your comments in the section below or to my right, depending where you're joining from. And I am more than happy to address your challenge while we're live. And the specific application of AI technology always depends on what data you're dealing with. It always depends on what vision you have. And we've so far discussed very high-level use cases of AI technology. And I want to recap this for everyone who's joining us. So we started with the concept of how can we achieve full vehicle autonomy, right? There are 6 levels of autonomy, and it's a stepping stone. It's a progression that companies can go through to achieve full autonomy. Right? We then discussed a few examples of how companies can use AI technology to improve the customer-facing experience. And we also discussed a few examples of how businesses can leverage AI to improve the business operations, right? Everything from the production to the manufacturing and distribution of vehicles, right? And this is an important domain to solve because car accidents today account for the majority of deaths for the younger generation, right? The generation of 16 plus, the individuals, depending on where they're from, who are able to drive a vehicle are in a position to use vehicles, but they're not well developed. They don't have the driving skills necessary. They may be under influence, and creating technology that can save lives, from my perspective, is definitely one of the altruistic goals that anyone can have in order to create a better, safer world. Having said that, there are many more commercial use cases of AI technology. Today, we see companies investing billions of dollars into AI technology. Companies who reach out to us are very interested to use AI, and they're willing to commercially commit resources to develop the technology. And it's just a matter of figuring out specific use cases, specific tasks that we can solve. So I want to emphasize this. AI can solve any domain problem of the automotive space, but the real question is, what problem, challenge, or frustration do you face? And that could be a good starting point. Another way to think of AI technology is from the perspective of what's not safe today, right? Operating a vehicle around pedestrians is not safe today. So then presents the opportunity. How can we use AI technology to help companies to create vehicles that would better deal with pedestrians, right? Autonomous vehicles, autonomous driving, leveraging technologies like object detection, semantic segmentation are just a few of the tools that allow companies to achieve this. And there are many ways to go about it. And if you are working in the domain, I highly encourage you to think about your specific workspace, your specific processes, your specific frustrations. If you have any, feel free to leave them in the comment section or to the right-hand side, depending where you're joining from. And I'm more than happy to answer them while we are live. Again, this is a live broadcast. I welcome everyone who's with us today. I welcome our future viewers and listeners. I do these live streams on a daily basis, and I want to give back to the community because I realize there's a disconnect between industry and technology. There's a disconnect between business and technology. And these live streams are meant to educate. These live streams are meant to inspire and share best practices for how entrepreneurs, decision makers, and executives can use AI technology to leverage the technology to solve industry problems. And I also want to emphasize that I run an artificial intelligence agency. And this is an agency based in Vancouver, Canada. We've been doing this for the last 8 years, and we've helped companies around the world to implement, develop, research, and make sense of AI technologies. And I encourage everyone who is interested to hear about our upcoming live streams where we discuss how to solve industry problems to go to our website, that's produbia.com, and subscribe to our newsletter. That way you will be one of the first to know when we go live and about our upcoming event. And also subscribe to us by clicking on the bell icon, depends where you're joining from. I want to welcome everyone who's here. It looks like we have people from Facebook, Periscope, LinkedIn, Twitch, and many other platforms. So I want to welcome everyone who's with us today. And if you are interested to dive deeper into the specific problem that you're facing, I highly encourage you to reach out to us and create an opportunity where we can speak face-to-face and we can discuss your specific problem. And the best way to do that is to schedule a discovery call with us where you can chat with us, you can ask questions, and we can give you the insights that you need to move forward with this technology. AI technology can be confusing, but it also can be very powerful when it's implemented the right way. So I encourage you to reach out and make a contribution to the conversation itself. This live stream is interactive. This live stream is meant to give you back something that you would like to apply in your life. And the best way to do that is to go to produbia.com/start. That's PRODUBIA.com/start. Okay, so I want to start wrapping up this particular live stream, and I want to start making a few remarks about the future of this technology as it relates to the automotive space. Today we see companies striving for the mission of achieving full vehicle autonomy. And this is an amazing vision to achieve, especially as we are aiming to minimize how many people die on the road or how many pedestrians are hurt because of vehicles. If we achieve the catalyst where the majority of vehicles are driving by themselves, they're safer than they're driven by people, then that to me is a better world, that to me is a safer world. However, there are many other ways to think about AI technology as they relate to the automotive space. And one of the best ways to leverage AI technology is to solve computer vision problems. So anyone who's joining this live stream who's interested to use AI technology, I highly encourage you to look deeper into computer vision technologies because they are today by far the best technology available to solve imagery and video problems. We can attach videos both inside the vehicles or outside the vehicles. We can attach cameras at the production floor of the manufacturing process and anywhere else where we think they're valuable. And we can use that data to make sense of the world. Visual data by far is the best possible we can achieve. Now, yes, we can combine it with other types of data sets. For example, we can combine images with sounds or audio. This is where we can better understand what's happening around us. And it's a great sort of cohesion to have in the AI system to use multiple technologies to understand the world. Having said that, an excellent starting point for companies today is to start to use visual data and then start to expand beyond that. Perhaps use language data or sound or speech data, etc. So I encourage everyone to look deeper into computer vision technologies and feel free to rewind and rewatch this live stream if you're interested to learn deeper about what are some of the most common computer vision tasks or problems to solve if you want to achieve full vehicle autonomy, right? We've mentioned so far object detection, semantic segmentation, and pedestrian detection. But I'm very excited to discuss these, and there's so many other use cases about computer vision technologies. If you're interested to dive deeper into CV, as it's always called, I encourage you to reach out and have a conversation. And if you are shy to discuss AI technology, I encourage you to leave a comment in the section below, or you can leave me a text and I'll get back to you on your time. And so for those who are interested, I'll just type the text number here, and then everyone is able to see that and sort of follow up with me that way as well. And the text is actually quite useful because some people don't want to actually a phone call, and they're rather text to get started. And this is a way to do that. So for now, I'm gonna paste that in, and you will see that right about now. Perfect. So again, if you are interested to have a further discussion with me about artificial intelligence, about the automotive space, I encourage you to text, and that way you can at least have a conversation with me one-on-one. I'm more than happy to guide you on that process. So we are concluding this live stream. I want to thank everyone who's been with us. We've had people join us from different social networks. We are broadcasting this on YouTube, Facebook, LinkedIn, Periscope, and other platforms. So I encourage everyone to be here. And it's been great to have you. I want to thank you, everyone who joined us, and I want to thank you for sticking around until this hour. And what I'll do next is I'll quickly check my calendar just to make sure I know what we're talking about tomorrow. So if you're interested, feel free to do that. Tomorrow we're discussing restaurant industry and its applications in AI. And the restaurant industry has taken a hit due to COVID, so definitely lots of insights to share on that domain as well. And I encourage everyone to subscribe to our broadcast so that you can know when we go live tomorrow as we discuss the restaurant industry. And that concludes our live stream. Once again, I want to thank everyone for being here, and I look forward to seeing you next time.